TSMC just announced their new N3 FinFlex technology and also new 2nm transistors. So, which benefits it brings to CPU, GPU, and AI chip design? Let's find out. In the context of new computer chips, technology node is a really big deal. At Technology Symposium, TSMC announced new different flavors of N3 technology that will launch later this year. They've got one N3 node optimized for high performance, and then N3E node, where E stands for efficiency, and this technology is tailored for low-power applications. In comparison to N5, N3E offers 34% reduction in power consumption or 18% performance improvement, and it will enable 1.6 times higher transistor density. N3 transistors are still done in FinFET technology, but they will be using new, so-called new circuitry technology called FinFlex. In order to enable the continuation of the Moore's law, chip makers had to completely reinvent the transistors. They had to move away from traditional planar transistors, as we know it, to new FinFET devices. This is how a FinFET transistor looks like. In FinFET, the transistor channel is stretched up as a vertical fin, which is then contacted on three sides by the gate. This FinFET construction makes the channel, so to say, three-dimensional and increases the effective area. So TSMC N3 transistors will use new FinFlex technology. Basically, it's a new sales library which gives chip designers a flexibility to pick up different fin configurations depending on the chip blocks. Let me explain. 3 to 2 fin transistors are the fastest, but the drawback is that they are leaky. Anyway, these are the perfect choice for the CPU cores because it's running at the highest speed, right? Then you can use 2 to 2 fin configuration, which is basically a trade-off between the speed and power. And there is a third option, 2 to 1 fin configuration, which is a good fit for ultra power efficient applications, for instance for GPU cores or AI engines. So designers can mix and match different types of cells on the same chip in order to optimize for the best PPA, so power, performance, and area. This thing is not new on its own, right? Because usually in every library, so in every technology node, you will be getting different flavors of cells to pick up if you want to optimize for performance, so for speed or for low power. And then TSMC announced the N2 transistors. This 2nm technology relies on gate-all-around transistors implemented using nanosheets. Basically, they took a structure similar to the fin in FinFET technology, turned it horizontally, and then stacked several of these sheets one on top of the other. And then the gate is formed all around them. That's why it's called gate-all-around. As you can see, it's more or less a vertical transistor. And this totally makes sense because lithography is limited, so let's grow vertically. It's basically like building skyscrapers in a large and very dense city. N2 technology is advancement over N3, and it gives 10 to 15% speed improvement at the same power, or 25 to 30% power reduction in the same speed. And this technology is also chiplet friendly, which means that you can integrate N2 chip into multi-chiplet package, and some of your other chips can be made in more mature and more cost-efficient process node. For instance, some of the analog full custom blocks can be reused from previous designs. I think multi-chiplet packaging will be getting more and more popular in the future because it allows designers to optimize for the best performance and price. Thinking of what will come next. Basically, we can take this nanosheet structure and then just shrink the width of these nanosheets and to bring it to the shape of nanowires, and in this way to fit even more transistors per area, right? However, for this, we will need to improve the lithography first. Luckily, new EUV machines, so-called high-NA EUV machines from ASML, are already on its way. So, perfect. Now, when to expect new 2nm transistors in our laptops? N2 is scheduled to begin production in 2025, which means that we will get it in our gadgets somewhere in 2026. And usually it takes 2 to 3 years between technology nodes. So we can expect that TSMC will go for the shift to the next process node. Maybe it will be 1.4 nanometers or 14 angstroms, starting somewhere in 2028. But this is not official yet. And at this point of time, TSMC will definitely get new high-NA lithography machines, so new UV machines from ASML. They've actually mentioned that they're getting it in 2024. So they will likely use it for the next process node. This new generation of EUV machines is a really big deal. It will enable printing of almost 2 times smaller chip features, which of course will allow much higher transistor density. And also new tool processes the wafers much faster. Beautiful piece of engineering. Actually, Intel is expected to be the first who gets the industry first TwinScan machine for a test setup. And they are planning to use it for high volume production from 2025 onwards. So basically for their 18A process node. Exciting stuff. Also, at the Technology Symposium, TSMC talked about advanced packaging, the chip-on-wafer and wafer-on-wafer packaging, which is already in mass production for N7 and will be getting to N5 in 2023. But this is a topic for another video, which I actually made about half a year ago, so I will link it here. Make sure to share this video with your friends. And if you want to support me creating these tech videos, the link to the Patreon is below. Thank you for watching and see you in the next video. Ciao!